Our Earth is made of 4 layers: crust, mantle, outer core, and inner core. Inner core heat up mantle, then cause the crust to move around. The crust move around in different directions. When they get stuck, pressure builds up. Pressure eventually increases out the energy, and this is what earthquake is. Over 90% of all earthquakes happen in the rings of fire. In 19th of September 2017, local time 1:14, there was an earthquake of magnitude 7.1 happened in Mexico. The earthquake caused damage in the Mexican state and a great Mexican city area as well. More than 40 buildings were collapsed. 370 people were killed by the earthquake and related building collapse, including 228 in Mexican City, and more than 6,000 were injured. In that case, we can say that earthquakes don't actually kill people, but the failure of a structure or building does. This is where earthquake engineering or structural engineering comes in to fix the problem. Earthquakes usually generate pedestrian horizontal and vertical accelerations. By adding bracing can help increase the stiffness of structure. Stronger column design is much better. Stronger connection, avoid irregularity, increase ductility. In workshop 1, we will build a structure with dry spaghetti, wooden stick, blue tape, paper to resist a handmade earthquake. By using the knowledge we gained in the lecture, by adding bracing and strong column and strong connection, we increase the stiffness of structure. And this is the result.
Are you ready, guys?
Are you ready, guys?
Yeah.
Like I'm doing like I'm shaking not ready. Okay.
Earthquake also cause landslide, electrification, no soil, and angle of repose is the main key feature we're looking for in this. Factor of safety. This equation shows the stability of the slope. Factor of safety often needs to be greater than 1.2 in order to consider it as a stable slope. In workshop 2, we create a 2D slope and measure the geometry by estimating the volume of the slope. Then by simply pushing the box to pretend the horizontal force applied by the earthquake, this allows us to see the change of inclination of the slope. Then we repeat the process for 5 times, then we plot the graph on Excel, and then which allow us to see the trend. Top left show the record on 2017 Mexican earthquake. The maximum horizontal acceleration is roughly about 0.4 g. Bottom right show the result we get on that day. This shows the angle of repose of the materials about 32 degrees. Then by using the value of 0.4 g, the corresponding angle of inclination is about 28 degrees. But in order to have a factor of safety which is greater than 1.2, by doing some simple calculation, we find out that the angle of slope must to be less than 27.5 degrees in order to have a stable slope. Our goal in this engineering challenge is to learn from Mexico earthquake and to improve our build in both structural and geotechnical ways to prevent the earthquake as cause of disaster.